So, welcome to the fourth lesson in this wonderfully free subnetting course. In this lesson, we're going to talk about variable length subnetting. So, are you ready for a new concept? Let me start by asking you that. I hope so. As flexible as it is having a Class A, Class B, or Class C address, it still isn't enough these days. What we've covered thus far is known as classful subnetting. And that's where I told you that again, in the subnet mask, you've got all ones with a breakpoint and all zeros after it. You will always have that in a subnet mask, regardless of what you're using. In classful subnetting, like we dealt with up to this point, you're either going to have a 255 or a series of 255s in the subnet mask, or a 0 in the octets of the subnet mask. So it'll be a single 255 or multiple 255s, followed by a set of zeros thereafter in each of the octets. That's classful subnetting. If that were all there is to it, I could end this class right now, and we could just be done. And initially, I just want to clarify, initially that's kind of where they were wanting to go, because they thought that was all that was going to be needed, when the internet and networking first started to get established in the world. Classful subnetting, however, is not adequate for all situations. Take, for instance, an example wherein you have a corporate headquarters and a regional sales office. You will need 3 networks to connect each of these. One for the headquarters, one for the regional sales office, and one for the actual network link between the 2 locations. If you used classful addressing, you would only have 1 network available. What now? Buy 2 more Class Bs? Well, if so, you would have to use an entire Class B address just for the link between the 2 sites. Recall that each Class B address has an available 65,536 addresses in it. This means that since you would only need 2 addresses, one for the router at each site, you would be wasting the rest of the addresses in that Class B group of addresses. So imagine over 65,000 addresses that have actually gone to waste, that couldn't be used anywhere else on your network because those were only used in between those 2 points. It's no wonder we were running out of addresses. Something had to be done. Now there is a solution, of course, and it's called a lot of things. Classless subnetting, or CIDR notation, CIDR, which is classless interdomain routing, pronounced I've heard it pronounced either CEDAR or CIDR. Most people call it CIDR notation or CIDR domain routing. You also have VLSM, which stands for Variable Length Subnet Masking, or just plain subnetting. We're going to stick with the generic term subnetting, since that always seemed the most descriptive to me. Recall previously that we had 3 options: Class A, Class B, or Class C for subnet masks. Now, with subnetting, we have many more options. In classful subnetting, we set our masks on the hard boundary of the octet, like this. In other words, that breakpoint in the subnet mask always fell on one of the decimal notations, or the dot notations, in between the octets. Again, you were only able to use, in classful subnetting, you were only able to use a 255 followed by a 0 in the octets, nothing else. Let's look at our original example. We had 128.32.15.22. We know that this is a Class B address because the first octet is a 128, and it looks like this in binary. And because that first octet starts with a 10, we therefore know that its subnet mask looks like this in binary. In short, what we have is this. The first 2 octets are 255.255, or 81s.81s. The last octets are 0.0, which are 80s.80s. Nice, but somewhat restrictive. Actually, quite a bit restrictive. What if we move the subnet mask boundary from where it is to a new place? Say, for instance, 1 bit to the right, like this. Now we have something completely new. We have a classless subnet mask. While we're moving network boundaries, what if we move them some more? What if, for instance, let's just get radical here, we move the network boundary 3 bits over, like this. Now we've got flexibility. If, however, 3 is good, 14 would be even better, right? Can we really do this? Sure. But what exactly have we done? Well, remember that in order to figure out the number of networks and hosts, we count up the bits and use the power of 2. With this, we learned that a Class A address had 8 network bits, that first octet, and 24 host bits in the last 3 octets. That yielded 256 possible networks, or 2 to the 8th. Each one of those networks, or subnetworks, would contain or have the ability to have 16,777,216 hosts, or written 16,777,216 is still the same as saying 2 to the 24th hosts. Let's apply the same to the above examples. In this example, we have 17 network bits and 15 host bits. So 2 to the 17th would give us 131,072 possible network combinations, or subnetworks that we could create, and it would give us 2 to the 15th, or 32,768 possible host combination numbers that we could use. So what have we done? We've taken our Class B network and we've carved it up into 131,072 individual networks, each with 32,768 hosts. Let's try our second example. Now we've carved up our original Class B address into about 500,000 individual networks with about 8,000 hosts in each of those networks. You ready for the last example? Wow. Now this is really pushing the envelope, huh? Now we have over 1 billion networks, each with only 4 hosts. That's a nice concept, but what's the use, you might be asking? Well, who would want something like this? I use this example because this is actually a very common subnetting scheme for a point-to-point network segment, or a point-to-point network link. Remember our example a couple of slides back, where we had 2 different locations, each with routers that had a point-to-point link between them. Imagine now you're the owner of an internet service provider. You own the Class B address 128.32.0.0. You need to conserve addresses. With a Class B mask, you use 16 bits for the network portion and 16 for the host portion. Remember that you only have one network, 128.32.0.0. That's all you're allowed to use, with 65,536 hosts. Now, wouldn't it make sense to be able to use some of those host bits as network bits and kind of sell off, if you will, these newly created networks? If we were stuck with the Class B address mask, we would only support one customer. You would probably choose 128.32.0.1 for your router as the ISP, and you would give your customer 128.32.0.2. The problem is that the other addresses, 128.32.0.3 all the way through 128.32.255.255, in this example would actually go unused. What a waste. Through the magic of subnetting, however, we can divide your Class B address with a 30-bit mask. Now, instead of supporting only one customer and wasting all of those addresses that can't be used by anybody else, you can support over 1 million customers all off of one measly little Class B address. So here's the summation of this lesson. When you're moving the network or the host boundary to the right of the classful boundary, that's actually getting into what we term subnetting. Now, the entire thing that we've talked about all through these lessons really still qualifies as subnetting. But when you're dealing with variable length subnet masks that aren't actually a classful boundary on the dot notation in between octets, when you're moving that boundary between networks and hosts up and down that line of the IP address, now you're really getting into subnetting as it's defined. So how many masks are there? Well, there's a lot. Here are all of the subnet masks that are actually available. So do you see the pattern? Just remember that each time we borrow a host bit, we say borrowing it, we double the networks and halve the hosts because of the powers of 2. Remember also the duct tape rule, where you see a 1 in the subnet mask, mentally just duct tape it down, that portion of the IP address, so it doesn't change. Can it get any easier? You bet. Instead of saying The network is 200.23.56.0 with a mask of 255.255.255.192. Networkers typically use a shorthand method wherein they count up the network bits in the mask and just use that number instead. For instance, instead of saying all of that gibberish that I just listed out there, we can just say the 200.23.56.0 slash 26 network. Here are some examples of what I mean. Now, this is getting into CIDR notation, but if you'll notice, the slash number, the number that follows after the slash, the forward slash, when you're listing out CIDR notation, is only listing out the number of bits used in the subnet mask with that IP address or that network address. So for instance, you would start out the first octet with all 8 bits. That would be a /8/9/10 consecutively all the way up to /32. That would use a subnet mask of all 255s. So instead of our old familiar 128.32.0.0 network with a 255.255.0.0 mask, we can now simply call it the 128.32.0.0/16 network. Do you need some practical examples? Well, that's not a problem either. What else are we here for? So let's say you have a Class C network. This means that you have 24 bits that you cannot change. They are duct taped, in other words. And you have 8 bits that you can change. You need to create as many networks as you can that have at least, and this is going to be the key here, when you get to the Network Plus exam and when you get to the CCNA or even the CCNP exams and you're dealing with subnetting questions, look for the words at least. And I'm going to go into some more detail on this later on, but look for the words at least. So let's say you need to create as many networks as you can that have at least 20 users in each network. Using the powers of 2, we can see that using 4 bits of the 8 total that we have to play with would only yield 16 hosts, or 2 to the 4th power per each of those networks, or each of those subnetworks. Only 16 hosts in each one. That's not enough. We would therefore need to use 5 bits for the host portion, since 2 to the 5th will yield 32 hosts per subnet. That's at least 20. Going back to that term, at least, that's at least 20. This leaves you 3 bits for the network part. So how many subnetworks have you created? 8. Why? Because 2 to the 3rd power is 8. 3 bits are used for the network. It sounds simple here because I'm purposefully boiling it down to its simplest terms. Here, however, is what a similar question might look like on a test. You might get a question like this. You are the network engineer of a new startup company. You have just purchased the Class C address of 199.56.200.0. You need to split this Class C address up between the 5 floors of the building you manage. How many hosts per subnet will you have? 3, 5, 32, or 16? Notice how they word the question. Test writers typically try to make their questions as vague as possible by throwing in a lot of extra junk to confuse you. They give you the IP address. Do we need that? No, it's irrelevant. The building has 5 floors. Who cares how many floors there are? While you're giving me useless info, why not give me the address of the building and the boss's name too? I mean, why not? Again, it's all useless information in that question. Do not let this extra information distract you. Your job is to ferret out the pertinent information and leave the rest behind. So let's dissect this question. It's a Class C address. This means that the classful mask will be 255.255.255.0. So get out your duct tape and go to work. We need to divide it into 5 networks, we know that. For this we use the power of 2. 2 to the 2nd power equals 4. That's not enough, that's not 5. 2 to the 3rd power is equal to 8. So we know we'll need to use 3 bits, 2 to the 3rd power, at least 3 bits for the network portion of the subnet mask, since 2 isn't going to be enough. 3 bits on a subnet mask look like this when written out in binary. This leaves 5 bits over here on the right for the hosts. Since there are 5 bits and each bit can represent one of 2 values, we use, surprise, the power of 2 again. So 2 to the 5th equals 32. And basically that's the same as saying 2 times 2 times 2 times 2 times 2. Now, if you need good practice questions on this lesson, I provided a PDF download just below that will give you some of those practice questions and scenarios to start your preparation for handling subnetting questions on a certification exam. And these are going to start moving toward questions that are very similar to, if not exactly, like the ones that are on the Network Plus exam more specifically. I also want to remind you that if you have any questions on this material or any comments, be they positive or negative, it can even be flame mail or comments as long as it's constructive, for me. I welcome them in the discussion below, or you can email me at support@acenetworker.com and I'll try to answer those for you ASAP. Thanks again for watching this lesson. I hope you got a lot out of it, and I want to invite you to watch the next video in this same free course lesson where we're going to talk about supernetting. Also, be sure to use the link below to get on the waiting list for my Network Plus training course, where I'm going to give you all of this that we've had in subnetting, as well as a thorough and hopefully exciting instruction on how each of the technologies work in networking and how to learn and understand them with ease. More importantly, I'm going to show you how to pass the Network Plus exam with flying colors. And remember the material for as long as you need to. So I look forward to seeing you in the next video lesson and look forward to you getting in the Network Plus training course. See you there.